Work is the amount of energy that you give or take away from an object. If you give an object energy, you're doing positive work on it. And if you take away an object's energy, you're doing negative work on it. If you push your friend on a skateboard, giving him kinetic energy, the work you've done is positive since you've given energy. And the amount of work that you've done is just KE, since that's how much energy you gave. If your friend runs into a brick wall which stops him, the brick wall did negative work since it took energy away. So the work done by the brick wall was just negative KE. This is one way to determine how much work was done. Just figure out how much energy was given or taken away. Another way to determine the work is by using the formula work equals FD cosine theta. F is the force that's doing the work. D is the distance the object travels. Theta is not just any theta in the problem, it's the angle between the force and the direction the object is moving. Oftentimes the force is in the same direction as the motion, which makes theta 0 and this formula turn into just work equals FD. If we lower an object with constant speed, we need to apply a force upwards equal to the weight of the object. Similarly, gravity applies a force downwards equal to the weight of the object. We can use the formula FD cosine theta to find the work done by gravity in this case. The force is just going to be mg. The distance the object travels is h. The angle will be 0 since the force of gravity points in the same direction that the object's moving. So the work done by gravity is just positive mgh. We can do the same thing to find the work done by the force we apply upwards. The only difference is that this force points in the opposite direction of the motion, giving an angle of 180. In other words, the work done by our upwards force is negative mgh. Remember that the work done by gravity is always plus or minus mgh. It's positive if the object's moving down, and it's negative if the object's moving up. Even on an incline with friction, the work done by gravity is just positive mgh, the vertical distance the mass moved downwards. If we want to use the formula FD cosine theta to find the work done by the normal force, we plug in mg cosine theta for the force. We plug in the distance d for how far it goes. But you can't use the theta of the incline for the angle in this formula. The angle we need to use is the angle between the force applied and the direction of motion, in this case 90 degrees, which means the normal force does no work. In fact, all forces that point perpendicular to the direction of motion do no work. Forces that point in the direction of motion do positive work. Forces that point opposite the direction of motion do negative work, and forces that are perpendicular to the motion do no work. This means centripetal forces never do any work since they're always perpendicular to the direction of the motion. Don't forget that because the magnetic force is required to be perpendicular to the velocity, the work done by the magnetic force is always 0. The area under an F versus D graph gives the work since the work is F times D. The work energy principle says that the total work done by all forces on an object equals the change in kinetic energy of that object. In other words, 1/2 mv final squared minus 1/2 mv initial squared. There are lots of different kinds of energies an object can have. An object has kinetic energy if it's moving. An object has gravitational potential energy if it's at a height h. A spring has energy if it's stretched from its equilibrium position. Careful, the spring energy is not kx, that's the force a spring exerts. Thermal energy is generated by friction or air resistance, and you find it by using F times D. Heat is technically a transfer of energy, and if you heat up an object, you can change its temperature or change its phase. The simplest formula for the electric potential energy is the charge times the electric potential. The electric potential energy stored in a capacitor is 1/2 CV squared or 1/2 QV. The reason we care about energy is that the total energy is always conserved. In other words, the total initial energy equals the total final energy. Power is defined to be how much work a force does in a certain amount of time. Since work is just the energy transferred, power is also equal to the energy per time. Since energy and work are measured in joules and time is measured in seconds, power is measured in joules per second, which we call watts. You usually have to rearrange this formula so that you can find the energy. The energy is going to equal the power times the time. If a question involves a resistor, you can use the power formula for a resistor, IV, or I squared R, or V squared over R. Multiply by the number of seconds the resistor was being used and you'll get how many joules of thermal energy were created by the resistor in that time t. Since power is the work per time done by a force and work is F times D, the power is just FD over T. But D over T is just the speed, so power equals force times speed. In other words, the rate at which a force gives energy to an object moving with speed v is just F times v, the power.